Hi everyone, I'm Dr. Nick Berman and welcome to this next video from our Foundations for Research Data Management for GIS. Today we're going to look at how we apply some standard techniques from research data management to GIS. So it's great to have you back. Let's dive straight in. So to kick off with file naming conventions, it's really important to have consistent file naming conventions. There's some good rules that it's good to follow. So firstly, stick with only letters, numbers, hyphens or underscores in your file names. So no spaces, no punctuation, nothing like that. And then whatever format you use, be consistent. So consistency is key for this sort of thing, even if that's just consistency within one specific project. And so by consistent, I mean, use underscores consistently, use hyphens consistently, and then either use camel case or not camel case, depending on what you want to do, but be consistent with that. A camel case being where you start the first letter of a word with a capital letter and the rest is in lowercase. And a couple of optional things that I want to throw in as well. If you want to benefit from default ordering, start your file names with a date, but start it with year, month, day. And then by default, ordering it alphabetically by name, we'll put them in date order. And also, never ever use the word final in a file name. That practically guarantees that you'll have to do some revisions to the file. Use version numbers instead. So start with 1, 2, 3, or 0, 1, 0, 2 if you think you might get to double figures. So these are some good approaches. Ultimately, these are all based on the RFC 3339 and ISO 8601 standards. So if you're interested in the gory details, check out those links. Some bad examples of file names. Here we've got myabstract.docx. Capitals are not consistent there. And then we've got Joe's file names using spaces and punctuation. So no spaces, no punctuation. Figure 1 PNG, Fig 2 PNG, they're not too bad, but they have got spaces in, which would be good to avoid. And then lastly, that horrible example at the bottom there, delete this and your career is over, not a good start, but also all sorts of random characters in there. And certainly on Windows, it will not let you put a star or a bracket in the file name. It will give you all sorts of error messages, so avoid those. And here's some really good examples. So we've got a couple here with dates. So that one at the top, 2014 June 8th, abstract for SLA. Here we've got hyphens and underscores used in a systematic way. So hyphens for the date and underscore to separate the date from the title. Joe's file's names are getting better, so well done, Joe. Fig 01, Fig 02, and a couple of other nice examples. So what it is, figure, then 01, 02 for whatever figure number it is, and then a description of what it is, scatter plot, talk, length versus interest. And then lastly, another date one, another consistent naming one. So 1986 this turn, and some raw data. If you want more information on file names, there's some slides from Jenny Bryan, so the link's there. Really check those out if you're interested. And I'd really start small, start trying to be consistent with file names for one project or one area. That's fine. You don't need to do all of your files in one go. Next up, I want to talk a little bit about backups. So your data is vital to your work. Everything that you do, the data is really important. But what is your data? It's worth spending a few seconds thinking about this. So it could potentially be anything. Only you know what your data is. So, it could be the research paper you're working on at the moment. It could be the analysis you're doing right now. It could be the questionnaires you've collected over the last 5 years. It could be the DNA you've just analysed, and so on and so on. So there's a huge amount of stuff that it could be, and it's important to think about, okay, what is your data? It's not just necessarily the immediate things you think of. And if you've got a good idea of what your data is, where is your data stored? So yeah, spend a few minutes thinking about this now. So have you got a laptop? Is it stored on there? Is it stored in some institution organized storage? So does your university or institution have a local data center, something stored there? Do they also organize some cloud storage? So OneDrive is very common in institutions who use a lot of Microsoft stuff. Is your data stored on there? Or is your data stored on your own organized cloud? So that, I mean, something you've signed up yourself. Could be OneDrive, Dropbox, Google Drive, and so on and so on. It's possible you don't know. Um, it's worth trying to find out where this is. And your data is not all stored in one place. There'll be various different places for different bits. So try and get an idea of where your data is stored. If you're watching the video, pause it, spend a few minutes, jot down on the list, where do you think your stuff is stored? So have a pause, have a go with that. So talking about backups, we often have something called the 3-2-1 rule. And that means that you should ideally have 3 copies of your data. So it can be 1 copy that you're working on your computer at the moment, plus 2 copies elsewhere, and ideally stored on 2 different devices. So this could be your computer, it could be an external hard drive, something like that. And one of them should be what we term here off-site. So by this I mean stored in a different place to your main computer. So a cloud provider would work. If you store a backup disk somewhere else, that would also work. And if you're working in an institution or for an organization, they probably do some backups already. But so what do they back up? It's well worth spending a little bit of time finding out. On the IT pages or the IT help pages, there will be some information. So this table below, this is from UCL, and they had a PDF called UCL Data Storage Options, which lists all of their different data storage options. So they've got a list of services across the top. So you can see SharePoint there, OneDrive for Business, and then they've got what they term file store at UCL, N drive and S drive. So these are network drives. And they've got a couple other bits and bobs. And they also mention commercial cloud storage, so Dropbox and Google Docs that you sign up for yourself. And there's various things that to think about, particularly in this, what's shown here, backup and recovery. So how are those files backed up? And it will describe about, it says how they're backed up and, are there regular snapshots, how long they're kept for, and so on. 2 really interesting phrases in that table are recovery by user and able to self-restore files. So that means if you delete a file off one of these types of storage, particularly S drive and N drive I'm looking at here, you can restore that file yourself. How do you do that? Well, I have a vague idea. I used to work at UCL, but I never really looked into it. I should have. Can you do that in your system? Where are your files stored? Can you do that yourself? When you get some time, try it out. It's much, much easier to try restoring a file when you have plenty of time, there's no stress, rather than when your laptop's disappeared, your laptop's stopped working, and you must have that file immediately. It's a lot easier to do it now while you have a little bit of time. And just to mention in passing, archiving. So archiving is long-term storage, and it is kind of different to backups. Backups are a secondary copy. Archiving may well be your only copy of that data for the long term. So we'll talk more a bit about that in session 3, when we're looking at FAIR principles and GIS. The last thing I want to mention briefly is what we term disaster recovery. So this is what do you do when things go wrong? And the most important thing I can stress here is try this out before you need to try it out. It's much easier to try this out in a relaxed situation rather than a stressful environment. And before we get onto that, the other thing I also need to mention is multi-factor authentication, MFA. So this is when you often get a 6-digit code sent to your phone if you're logging into something. And so what happens if you lose your phone? If they send a code to your phone and you haven't got your phone, what do you do? So some services like Google or GitHub have a backup code. So you can, when you sign up or when you update these details, you can download a list of 20 different codes and you can use those to log in instead of the code sent to your phone. Of course, that means you need to have those codes available to do this. Some services will let you have a backup phone number or a second phone number. So this could be a trusted friend or relative or something like that. Sometimes you'll have to phone up a help desk and talk to someone. So particularly institutions, so UCL is a great example of this. my password expired and I'd reset my phone, so I didn't have the authentication app on there. So I had to phone up and say, prove yes, I am Nick Bierman, and yes, I need to reset my password, and yes, I haven't got my phone, so please can you do it? And they did, but it just takes time. Some institutions, you have to submit a request, an online form, and it can take 24 hours to get sorted. So let's have a little exercise. So pretend your laptop's died. Put it in a separate room if you like, or have your partner take it away, or if you're using your laptop to watch this video, just imagine. So what happens? How do you access your files? What is the most pressing thing you're working on? How can you access it? How can you access your email? How can you access your calendar? So pause the video, take a few minutes to think about this and work out what you'd do. And once we've done this, we do a slightly different version. So this time, pretend your phone has been stolen, or give it to your partner, take their way, whatever. How do you access your email? If you need to log on to anything using that multi-factor authentication, what happens? Have you got a different code? How do you get into it if you don't have your phone? So writing up what we have just covered is called a data management plan. So this is in terms of what data you have, where it's stored, how you access it, that sort of thing. And sometimes you need one of these for a funding bid. It's not that unusual for that to be requested now. There are some great examples from DMP Online, examples of data management plans from successful funding bids. Very typically, these are project related. So you'd write up a data management plan for this project and talk about the data for this project and where it's stored and all that kind of stuff. We have some information that's not project related, so our standard operating procedures, that's where it could be stored. Stuff, say, for example, to do with your email, your calendar, or kind of general files that are not project based. The SAP document is a reasonably formal way of doing this. It's possibly overkill for an individual working on a project, but the key bit is make sure you write this down. It doesn't really matter how you write it down, as long as you've got it written down and access it somewhere, and as long as you can find it when you need it. So if your laptop does get stolen, or your phone gets stolen, or whatever, how do you access that document? Have it somewhere you can get hold of it. Thank you very much, everyone. It's great to have you here, and thanks to NFDI4Earth and the Digital Research Academy. See you next session.